Thank you, Ivan. So first, we're going to talk about using Git with just a single local branch. Next, we're going to talk about using Git with multiple local branches. And then lastly, we're going to talk about how to use Git using remote branches. Cool. So that's the general overview for what we're doing this morning. So I'm going to make a Git repository first, so we can actually test all this fun stuff out. I'm not going to do it in the same folder where I'm writing my notes, because I don't want the notes file itself to interfere with all the Git stuff that I'm tracking. So I'm going to make a separate folder here. Call it Git demo. And again, if you want to follow along, this is a good place to start following along. If you want to just run all the commands I am, get the same Git repository at the end. So I've made a Git demo. We're going to cd into the Git demo. We'll run a quick ls-a. Shows me there's nothing in here. That's what I expected, because I just created an empty folder. Great. Run git init. Tells me it initialized an empty Git repository. I do ls-a. I can see the .git folder now, so I know it's a Git repo. I run Git Status. So it does recognize that this is a Git repository. I'm on branch master. There's no commits, nothing to commit yet. So I can't really do anything interesting, but Git Status is acknowledging that this is a Git repository at least. So next, I'm going to create a file. Touch first file.txt. So that just creates an empty file. There's nothing in it at the moment. Just less first file. It's completely empty, but that's fine. We can use Git to track empty files. So if I use Git status, it shows me I have this untracked file. But I would actually like to add some text into this file. So I could just open up my editor and use VS Code to type into it or whatever. I'm going to take a little shortcut here. We're going to use echo.
Hey, Raphael, what command did you use to get out of after you put the less command in?
Q. Q gets you out of less.
Okay, thank you.
Yeah. So here, if I just echo first line of text, that just repeats whatever I typed. But I'm going to use some shell redirection here. So that text, first line of text, is going to get written into first file.txt. So now, if I look at the first file, we can see it has the first line of text in it. Great. So I've made some changes to my file in my Git repository. Git status tells me I have an untracked file. So if I want to commit this change that I've made, I'm going to git add dot, adding all the files in my repo. And then we commit it. Well, let's just run status and see what we've done so far. So I'm on the master branch and the working tree is clean. I've committed all my changes and not made any changes since then. So this should all be review up until this point, just doing some basic working and committing on a single branch. Okay. So now I'm going to add some more text to the file. We're going to use less to read the file again. So it's got 2 lines of text in it. But note that I have not committed yet. So the first commit has the first line of text, but that second line of text has not been committed yet. So this is a pretty common question that I ask myself. And I'm just like really in the zone coding for 15 minutes. Then I just kind of like wake up and I'm like, wait, what have I been doing for the last like 15 minutes? I want to like kind of reflect on what I've just accomplished after I'm, emerging from the zone. And so you can do that with git diff. Just typing git diff with no arguments, that's going to compare your most recent commit with your uncommitted changes. So here we can see this green line with the plus. This line was added in my uncommitted changes as compared with the most recent commit. All right, so I've diffed the changes here. I like them. I'm gonna add and commit them. Git add dot. Commit that. Now I've got 2 commits in my repository. So if I want to look at them and compare them, I can do that using Git Log. So now after typing Git Log, it shows me the list of all the parent commits of my current commit. So oftentimes that's going to be every commit in the repository, but depending on if there are branches in the repo, that might not show you every commit. It's just going to show me the parent of the current commit, the parent's parent, parent's parent's parent, all the way so on and so forth to the start of the repo. Right now it's pretty simple though, because we only have 2 commits. There's the most recent one I did, added the second line of text, and then the first one I did, in which I added the first line of text. So something I want to point out to you here is that there are a bunch of different labels for the commits here. There are different ways that we can refer to them. So I believe I mentioned this the first time around, but just to review, every commit has a commit ID. So if you want an unambiguous way to refer to a commit, a label that never changes, the commit ID is a good way to do that. This commit, 208.492, whatever, this always refers to adding the first line of text. So if I needed an unambiguous way to refer to a commit, the commit ID is a good way to do that. So we can also use these for our diff. So let's say I want to compare my current commit against this guy here, 208.49. I'm going to copy this and then run git diff and then paste in the commit ID. And that's going to show me a pretty similar diff to what we saw before, comparing what's in my current commit against the previous commit. So git diff with no args. So if you want to compare your current commit to another commit, you're going to have to specify the one for comparison, and then it compares it against your current checked out commit. Now note that there are other ways to refer to commits as well. So for example, you've got master. This is a label that refers to your master branch, but this label in particular is applied to a single commit. It applies to the most recent commit in the master branch. And then another label is head, which always refers to your current checked out commit. This is just like where you're at right now. This is like you presently, what you're doing, what you're looking at, that's your head, your active commit. And so here you can see also that head points to master. So that's saying that your current checked out commit is the tip of the master branch. And also this commit is the tip of the master branch. So you can have multiple labels that point to the same commit. So it's kind of like how in our programming languages, in JavaScript or Python, we can define an array or a dictionary or something, and then have multiple variables that point to it. And so we understand, because of like pass by reference in programming, that it's the same object, it's the same dictionary or whatever under the hood, and that we just have multiple different names for it. So it's kind of the same thing here with Git. We only have one copy of this second commit, but there are multiple different names for it. So I can use the commit ID, I can call it head, I can call it master, but I just need to know that these two labels, these are moving labels. Like as soon as I make a new commit, head is going to move. This is no longer going to be my head, but the next newest commit becomes the new head, whereas this commit ID is never going to move. So you need to bear in mind the difference between these permanent labels and the movable labels. Now, also, I'm going to make this a little bit more complicated for you. You can have relative labels. So sometimes you want to say, just give me the commit that's like one commit before this other commit. So most commonly is you're going to use the tilde character to refer to a parent or grandparent commit. So for example, we're going to see this in just a second. If you see a label like head tilde 1, this is one commit before your current commit. So similarly, head tilde 3 is 3 commits before the current commit. So this gets very commonly confused with a different syntax. Which is the caret. Some people can't tell these apart, but they actually do pretty different things. Generally speaking, the tilde is what you're going to want. You're not going to use the caret as often, but I'm going to explain what it does just for comparison here. The caret refers to which parent of the current commit. So head caret 1 is the first parent of the current commit, and head caret 2 is the second parent of the current commit. So using tilde is pretty useful because every commit, well, most commits are going to have multiple parents. The first commit obviously doesn't have any parents because it's your first commit, but every commit after that is going to have like multiple generations of parents. So you might want to compare a commit versus the one 2 commits ago, 3 commits ago, 5 commits ago, whatever. But when you're talking about multiple parents for the same commit, this is much less common because most commits only have one parent. There are some situations when we merge branches together, in which case a commit can have 2 parents. So in those specific cases where a commit has 2 parents due to a merge, you might have to use this syntax to disambiguate which parent you're talking about. But in a lot of common situations, you're not going to use this syntax. So let's say, I want to compare my current commit against this previous commit, but I don't want to get the commit ID because that's just like an extra step I have to do. I have to do the Git log and copy and paste the commit ID into this git diff command. Like, let's say I just know, whatever one commit back is, I want to compare my current commit to that guy. Git diff and head is the label for my current commit, ~1. So this is going to compare my current commit, which is head, to the commit that I've named, which is head ~1. And so that's going to show me the same diff because head ~1 right now refers to the same commit as 20849, etc. All right, do you have any questions about just the diff and the relative commit labels, stuff we've seen so far?
Is it all right if you just repeat what the head 1 did compared to the other git diff when we copied?
So here, doing git diff with this specific commit ID, I'm comparing my current commit with this specific commit, which, based on the log, it's this commit where I added the first line of text. But so anytime I run this command, it's going to compare my current commit against this exact commit. So if I continue developing on this project and I run this command again, it's going to, again, compare that current commit from the future to this one very first commit. Whereas that's different from doing it with head ~1, because the head ~1 is relative. That's always going to compare my current commit with just the one commit previous to it. So if I'm, doing a whole bunch more work on this project, I do 10 more commits, and then I run this command again, that's going to compare my 12th commit against my 11th commit, because it's always just comparing against the current one with the one before the current one. That's what head ~1 means.
All right, thank you.
Yep, you're welcome.
Hey, Raphael, do you mind just going over what like the parent of the commit would be?
Yeah. So, the parent of any commit is just the one that came before it. So it'll be easier to see in just a second, but let's go with the log here. So this commit is a parent of this commit.
Okay, so when you're saying the caret you'd only ever have like the second parent would be like if one commit pointed to two different commits.
Mm-hmm.
Okay.
And I'm sorry, I think I had that backwards actually. This commit would be a child of this commit. Sorry, I said that the other way around. But yeah, because I'm just like doing work and creating a commit, and then doing work, creating another commit all on one branch, each commit only has one parent. So it's only when we try to merge two branches together and then it creates a new commit as a result, that commit is going to have two parents. So that's not as common of a situation. All right. So now we're going to learn a little bit about going back in time. So I'm just going to look at the current state of this file here. If I look at, if I look at first file.txt, it's got these two lines of text in it. Do Git status. I'm on the master branch, nothing to commit. Working directory is clean. So now if I want to go back in time and see what was going on at this previous commit in the past, I can use the checkout command. Checkout will change your head to some other commit. So I think of it as like checking out a book from a library, but this library only lets you check out one book at a time. So that's kind of the special restriction here. So I'm going to put away the tip of the master branch, and instead we're going to check out head ~1. So one commit before the head of the master branch. Now you'll notice as soon as I do this, I get this kind of scary looking error message. Well, it's not an error, but it's a warning message. that I am now in detached head state. I can look around, make changes, but it's encouraging me to discard the commits that I make before I switch back. So this sounds really scary, but what this means is that head is not in the present. Generally speaking, in Git, your head is supposed to be the tip of some branch. But if we look here at the Git log, head, it's not even showing the second commit because we're checked out to the first commit. But now it's showing that head is the first commit, which is not the tip of the master branch. So you'll note that we don't actually see the master label here. We just see the head label. This is one way we can tell that we've gone back in time. We've checked out a commit that is not the present. And so the reason why it's telling you not to make commits here is because that would basically create like a time traveling paradox. You know, you go into the past and make changes, like, well, what does that do to the future? It's like all those like episodes of The Simpsons where they go back in time and like somebody steps on a butterfly and then they go back to the future and then the president of the United States is a lizard person or something like that. This is one of those kind of situations, except Git has these like anti-lizard people defenses like in place already. And so they just give you this warning message. They prevent you from committing when you've gone back in time. It's still useful. You can look around and see how things used to work. If you want to, you know, do some debugging, get some historical perspective on a project, you can go back in time and then run the app from this other commit in the past. Yeah, so that can be useful sometimes. Just remember not to commit. Now, if I want to get back into the present, I could use the commit ID for that present up-to-date commit. But probably what's simpler is to just use the master label. Because remember, the head label went back with me when I checked out this older commit, but the master label is still referring to the most up-to-date commit from the master branch. So I'm going to get back to the present using git checkout master. I've switched back to the present. Nothing to commit. Edgar, got a question?
Yes, so you can do anything in the past, you just can't commit, right? Like as long as you don't commit, you can always check out to master and always go back to the present, right?
Yeah. And I mean, allegedly, you can commit. I've never done it. I don't know what to expect when you do that. Like, you're not supposed to do that, but I don't think the software like strictly forbids you from typing git commit.
Well, I should try it and see like what happens if like the computer blows up or something.
Probably. Hope that answered your question. Are there any other questions right now? No? All right, cool. Okay, so I've gotten back into the present. We're gonna add some more text into our text file here. Yeah, so it's got 2 lines of text. We're going to echo a 3rd line of text. Do a quick git status. So it shows me I've got some changes that I've not yet staged for commit. But let's say I don't actually like these changes and I don't want to commit them. So there are a few different ways that you can handle this situation. What I'm going to show you right now is Git Reset, specifically a hard reset. So this is a potentially dangerous command, so please pay attention, use this carefully. What I want to do now is get rid of all of my uncommitted changes. I want my most recent commit to be what's in my working directory. I want that to be, you know, the present state of my project, and then just forget about everything I've done since I've committed. So I'm going to do git reset. There's a few different types of resets. There's soft, medium, and hard. Hard reset is the most like permanent, the most destructive one. So be careful when you do hard reset. this is going to throw away all the changes that I've made since I committed last. So now if I do git status, there's nothing to commit. The hard reset will throw out any committed changes, any uncommitted changes. So doing a git reset like this, git reset -- hard with no other arguments should always return you to a clean state where you have nothing to commit. So this is pretty destructive, git reset -- hard, but at the very least, what I've just shown you here doesn't rewrite your Git history. So it changes, my working directory, but it doesn't change the Git log. So I still have the same 2 commits in my Git history. So that's great. It's not super destructive. So this next command that I'm going to show you is super destructive. This is going to actually rewrite your Git history. Now there's a time and place for doing this. And that time and place is on your local machine. If you have a branch that has already been pushed to GitHub, you should avoid rewriting the history, because then when other people pull down your branch, they're going to get some surprises if what they pull down conflicts with what they've already had. So that's the general rule of Git etiquette. There are a lot of commands that rewrite history, and there are a variety of reasons why we do that, but you should only rewrite history on branches that are private to your local machine. Once someone else has gotten to see your branch, like it got merged into master, for example, you should avoid rewriting history after that point. So I'm going to show you here, got our Git log with 2 commits in it. And I'm going to do a slightly different form of Git reset. So now I'm doing a Git reset, naming a commit. When you do a hard reset and name a commit, that's saying that this should be the most recent commit, and everything else after that gets deleted. This is like a super permanent action. Be very careful when you do this. Like, I only do this if I make a commit that is like so bad I'm embarrassed of it, that like I'm afraid that like if anyone sees this dumb thing I did, I'm going to get called out as a fraud and I'll like lose my job or something. And I just like don't want this anywhere in the source control where people can like dig through it and find out what the stupid dumb mistake I made. So I might hard reset and just completely delete a commit, just like, let's forget that ever happened. But again, you only do this for code that has never been pushed to a shared repository. So I git reset hard head ~1. This is going to completely delete this commit, and saying head ~1 is going to be the new present for this branch. So now head is at 20849, this commit. If I do the git log again, we have 1 commit. Okay, so we've got our first file right now. It's just got 1 line of text in it because I did a hard reset to delete that commit. So let's make things a little more complicated now. We're going to add a second file. I'm I'm gonna imaginatively, creatively call it second file.txt. Add and commit it. Add a third file. What? Oh, what am I doing here? Touch third file.txt. Git add dot. Okay, cool. So now let's look at our log again. So we've got 3 commits now. First, we've got that original classic commit from the start of the lecture, where we added the first line of text. Got another commit where we add second file, and then most recently where we added our third file. So let's say I want to undo some of my changes here. Now this time it's not the most recent change that is problematic. Let's say I like this third file. This is, perfect, beautiful code, best code that's ever been written. But this second file is not really up to our standards. It's got a bug in it or something. And we want to undo just this one commit. So I don't want to actually go back in time because I don't want to undo this third file. Because this was good work. I just want to undo this one commit kind of from the middle of our commit history. So the way we do that is actually not by rewriting our history, because like I said, we want to try to avoid changing shared history as much as possible. So what we do here, if we want to just get rid of this second commit, the second file commit, is we create a new commit, a fourth commit, that just has the opposite of whatever we did in this commit. And the way we do that is using Git Revert. I'm going to say Git Revert, and then I name the commit that I want to revert. So here, I want to undo the commit before our current one. So our current one, head, is good. I want to undo the one before head. So I'm going to do Git Revert head ~1. So this is going to make a new commit. So I have to create a commit message for it. So it just throws me into Vim. The default commit message is fine, just revert second file. That's what I did. I'm fine with this commit message. So I'm just going to go :WQ to save and quit out of Vim. Based on your configuration, that might open VS Code instead for you, but I never changed the default editor for Git, so it just uses my system default. Okay, so it says that it reverted that change. So let's see what our log looks like after running Git Revert. So now we've got 4 commits. This is what I was saying. We didn't actually delete our history, which is good. We don't want to actually modify old commits as much as possible. We want to just create new commits going forward into the future that fix problems. So we still have that second file commit, but now we've created a new commit, which just reverts it. This reverts commit, yada, yada, and that's this ID here. So now, by ls, we can see that I have the first file and the third file, but the second file has been removed from the repo because that was part of the commit that we reverted. So there's something important that I want to point out about reverting. And this is something that I think a lot of non-technical people don't really understand. This is like a mistake that I've heard PMs make, is that when we revert this second commit, that we haven't gone back in time. We have not gone back to a safe, stable version of the application. Reverting this commit creates a new commit, and the application is now in a new state that it's never been in before. So like the situation that I've seen in applications is, the developers are doing a whole bunch of work, and we make these 3 commits: first line, second file, and third file. And then it passes all the tests. We deploy it to production. But then after we deploy to production, people realize the hard way that there's a bug in this second commit, this second file commit, and we need to get it out of the live production application. So what they'll do then is revert this second commit and then just immediately redeploy, because there's a bug in production and we want to get the fixed version up to date and online as fast as possible. But I have to remind people that after you revert this second commit, you have to test it again. Because when you revert this commit, you didn't just go back in time to a safe, stable version of the application, because there was no published version of the application that had the first commit and the third commit without the second commit. So reverting just this second commit, you've created yet another new version of the application, which you need to test before you deploy it. So a lot of product managers who aren't really working with Git with their hands think of revert as just going back in time. But it's not. You're undoing one specific commit, which might interact with a lot of other commits. So this is something to also do carefully. You need to test after you revert commits. That's what I'm trying to say here. So does everybody understand what I'm saying about revert, how it creates a new commit? You're still kind of going forward into the future, even though it sounds like you've moved into the past.
So basically, we just need to make sure we test everything after we revert.
Right. It's always good to run tests. But yeah, just the critical insight here is that after you revert a single commit, you've created yet another new version of the application. So don't assume that you know that it works, basically. Okay, so I'm going to show you another way to kind of go back in time and change. Yeah, to go back in time, fix your mistakes and things. I'm going to show you another way to use checkout. So if I look at my log again here, so head and master are on the most recent commit. We are in the present in Git because our head is the most recent commit in this branch. Git status, we have no unsaved changes, so totally clean. So now let's say I want to recreate the past. I want to see how this repo used to look one commit ago. Use git checkout head tilde one, and then dot. So changing the syntax here slightly, we're adding an extra argument, this is period. But when you add the extra argument to git checkout, it actually changes how it functions in a pretty significant way. So without the dot, what this is saying is move head, move where this head label is to this commit, so that my currently checked out commit is something else. And then that's going to change the files in your folder that you're working with to match, whatever's in that commit. However, if you put a file or folder here, in this case, I've just said the entire project folder, what this is going to do is it's not going to actually move head. You're still checked out at the same commit, but it's going to change all of your files in your project so that they look the way they did at this commit. So it's going to recreate the past. So it's like if you go to some kind of historical reenactment society or some kind of Civil War reenactment or whatever, it kind of looks like the past, but you haven't actually gone anywhere. people have just like put on costumes to look like they're from the Civil War time period. So it looks like it's in the past, but you're still where you are. So I do git checkout head tilde1 dot. So now if I do git log, I have not moved head. I'm still on the same commit. But if I do git status, now it's telling me that I have this new file, this second file.txt. Because in the commit previous to my current commit, this file did exist. You know, I deleted it in the reversion, so it's not in my current master commit, but in the commit one commit previously, this file did exist. And if I ls, we can see it's right here in my folder structure, all three of the files. So if I decide that I like how the project works, you know, I can actually just like run the project at this point, you know, and go manage.py, run server, whatever. It's not committed in Git, but it changes all my files so I can run the application, see if it works how I expect it to. And if I like it, then I can just commit these changes. So to review, if you want to switch the currently checked out head to a different commit, let's hit checkout commit label. So commit label, I guess, is more generic because an ID is one form of label, but there are other labels that a commit can have. Now, if you want to recreate a past commit without switching head, check out commit label and then period. So this is one of my favorite commands, honestly, in Git. If you want to get back to a previous commit, you know, if something is busted in your current commit and you know it used to work way back when, you can recreate it using this command. I think that this is generally just lower risk than other Git commands people work with. I would be afraid if I was trying to, you know, fix my mistakes using Git Revert or Git Reset, it's more likely that I would accidentally do the wrong thing and mess up my repo and then just have more Git troubles for myself. But I just feel like using this syntax, git checkout with the commit label and then a period, it just feels a little bit safer to me. It feels like I'm less likely to accidentally ruin my repo. And so this has been a pretty effective technique for me. So this is as much as I have to tell you about working on a single local branch. I think we're about due for a break. And then we're going to talk about working on multiple local branches. So that's going to be with committing, or I'm sorry, merging and branching and stuff. Do people have any questions before we take a break? Questions? Any questions? Maybe we need 10 minutes to think of our questions. All right, well, it's 9:51 right now, so let's take a 14-minute break, come back at 10:05, and we're going to talk about Git branching. All right, welcome back, class. So now we're going to be talking a little bit more about Git and talk about working on multiple branches. So I can create branches and merge between them, different types of merges that can occur. Now for this phase of the demo, we're going to use some more advanced visualization techniques here. Going to use VS Code here so that you can track the contents of these files as we're changing them, and then also see my terminal at the same time. Because as I'm doing these branching and merging and switching between different versions of the application, there's going to be a whole lot of changes to these files. And so maybe it's easier for us to follow if we can see those happening in real time instead of manually checking the files that we want to verify. Now, generally I love using the command line for everything as much as possible, just right here, so I can feel like a real hacker. But I'm hoping that it's a little bit easier to see and follow doing things here with the integrated environment where we can see everything at once. All right. So continuing onwards. So we're working with multiple branches now on our local machine. So first, I just want to check what branches we have available. I'm just going to type git branch. So right now there's only one branch. It's the master branch. But note also that there's an asterisk here. So that's not just like a list item bullet. That's saying that this is my current checked out branch, the master branch. So I'm going to make another branch. Git branch again. So now it shows me that I have two branches. Still have the master branch. And it's my currently checked out branch. That hasn't changed just because I made a new branch. But we also have this other branch. It was supposed to be called develop. It looks like I mistyped the name of it. So I'm actually going to delete this branch really quick before we continue onwards. So to delete a branch, you just use the -D flag with git branch. It says it deleted my branch. So now git branch shows me that I've just got the master branch, just like I started with. So I'm going to recreate this branch actually with a correct name. All right, so that's cool. So now I want to do another git log and just look at all my branches compared to each other. But just doing the regular git log is not going to show me everything that I want to see. This is not quite descriptive enough in this case. So I'm going to do kind of a special, more advanced version of git log. You can use git log -- graph. So this is going to give me like kind of a pretty visual graph of the Git repository, showing how the branches connect to each other. -- all, I want to see all the commits in this repo, because normally it just goes from your current commit to its parents, parent, grandparents, etc. But it's going to miss like sibling commits or cousin commits, on other branches. So I want to get all the commits. I'm going to add the all flag. And then there's some extra information that git log can provide. I don't remember specifically what this adds, but decorate equals full gives you more information that I find useful for understanding your branches. So now running git log like that, this is what we get. So it actually throws this into less. So, I can scroll up and down and whatnot. And it shows us this timeline here of our commits. Right now, it's just a straight line because all of our commits have been in the same branch. But what I want to show you here is our labels. We've still got the head label, which points to master. This commit is the master branch, but also this commit is the develop branch. So I've just created a new branch, but I haven't done any work on it. So all this branch is at this point is another label that points to the same commit. Everybody see what I'm saying here? That all these different branches, all these different labels point to the exact same commit. So just like, in JavaScript, you can have multiple variable names that refer to the same object. I've got 3 different labels, really 4 different labels, whoops. 4 different labels that refer to this same commit. There's the commit ID, head, master, and develop. So just for simplicity, I created an alias for Git Log. So when I just type GL, it's going to do that full Git Log command that you just saw me type. So you could set up that alias for yourselves now real quick if you want to, or just type out the full Git Log, or just look at my screen when I run the command, because in theory, it should be the same. All right, so I want to see what's going on with the develop branch. So I'm going to switch to that branch. So again, we use checkout to switch our head. This is switching it from the master branch to the develop branch. And I'm going to use git log again. So this is showing me similar output. We can see that our one most recent commit has all 4 of these labels. It's got the commit ID, head, develop, and master. But now we can see that head is more directly pointing to develop instead of master. So develop is our currently checked out branch, even though develop and master are both referring to the same commit right now. Multiple labels with the same commit. However, since head is pointing to develop, that means that the next commit I make is going to advance the develop branch instead of the master branch. So let's actually do some work now to differentiate these 2 branches from each other. So I've checked out the develop branch. I do git branch, yeah, it tells me develop is my currently checked out branch. We can tell by the asterisk. We'll create a new file. I call it dev file. Add Okay, so I added 1 file to the dev branch. If I want to compare this now to the master branch, I'm going to do diff master. So this is a pretty common command that I run like at work. If I'm like working on some feature and maybe it takes me more than a day or whatever, I want to know how the feature that I'm working on is different from the master branch, because odds are that other people have been contributing to the master branch while I was working on my feature. So this is a command that I can run to see, what's the difference between my work in progress and the current deployed version of the application. So that gives me little clues about, things that I need to be prepared for, things that I need to accommodate in my own code. So here doing git diff master, this is showing me that a new file was added. That's the only difference between the master and the develop branch is this dev file.txt. It got added. So that's cool. We can see that now in the git diff. So now I want to merge these branches together. Let the master branch get all the benefits of the dev branch's work. So has anyone done a git merge before?
I did through GitHub, but I haven't done it through command line.
Okay, so does anyone have any expectations? If I type git merge master, what is this command going to do?
I think it's going to merge what you've done into the master branch.
Doesn't matter that you have the develop branch already checked out. So is it going to merge the master into the develop branch?
It's going to try. It's going to try to merge the master branch into the develop branch. So that's a good observation. I only have to name one of the branches. The branch that you name gets merged into the branch that you're currently on. So I'm just going to show you. In this case, nothing happens. So when I say git merge master, while I have develop checked out, that's taking the new work from the master branch and then applying it to develop. But in this case, the master branch didn't have any new work. The develop branch had new work that the master branch was missing, but the master branch didn't have any work that the develop branch was missing. So merging master into develop does nothing. To actually productively merge these branches together, I'm going to switch over to the master branch and then merge develop into it. Wait, I'm already on develop. Going to check out master. All right, so yeah, as soon as I change the branch, you can see the dev file disappears. So develop has the dev file, master does not have the dev file. So we see that change happen immediately. So now we're going to merge develop. So this is going to take the changes from the develop branch and apply them to our master branch. So the merge was successful. We can see the dev file got added into our master branch here. And also we get this message here, fast forward. So that's telling us what type of merge happened. So there are 3 different types of merges in Git. So the simplest type of merge is a fast forward merge. Let's see. So this is actually a really simple merge to do because Git doesn't even have to create a new commit for it. So if we look at our log here real quick, all of our branches are still in a single line. So we're not seeing any divergence. And again, all of our commits are on the same, or all of our labels are referring to the same commit. All that had to happen is we had to just move one commit. We had to move one of our labels up. So previously, the master label would have been applied to this commit. I might have forgotten to show you a Git log at that moment in time. But right before I did the merge, the develop label would have been on this commit, whereas the master label was on, I'm sorry, other way around. The master label was on the old commit because master was slightly out of date. The develop label would have been on our newest commit because I had just committed to develop. And then merging develop into master, all we had to do is move the label. Git is just saying like, okay, as of now, these 2 commits are the same. Just moving the label for master onto the same commit as develop. And the reason why we're able to do this so simply is because master was missing some changes from develop, but develop was not missing any changes from master. If they both had changes that they needed to get from each other, then the merge is more complicated. But given that they're kind of like on the same historical timeline, but one of them is just further into the future, the only thing you have to do to merge them is just move the other one into the future as well. So moral of the story is fast forward merges are the simplest merges in Git. You should hope that all of your merges are fast forward merges. It's not always going to work out that way, but these are definitely the simplest merges to do in Git. Least likely to cause you other problems down the line. Okay, so let's try a more complicated merge scenario. Okay, so I'm on the master branch currently. Hang on a second. So we have a file that exists only on the dev branch. Now I want a file that exists only on the master branch. All right, so I added and committed. So just adding this file into the master branch, this master file.txt. We're going to check out the develop branch, and then we lose the master file because that only existed in the master branch, not in the develop branch. Now in the develop branch, we're going to add some text to this dev file. So it's empty right now, but our develop branch is going to have some more text in it. So I run my echo command and it dumps the text right in the text file. I guess as long as I have this open in VS Code, I could have just typed it in there normally, but I just love my command line. So I've added some text to the dev file. We're going to add and commit that. Now let's get the log again. So now things will look a little bit more interesting. We can see that our branches have diverged because now develop has some work that master does not have, and master also has some work that develop does not have. So this is what that looks like in our little Git graph. We can see, for this commit, this little asterisk is, representing that node, and we can see that it has branched off slightly from this main line here. So develop is the furthest into the future. Yeah, this commit was at 1024. This commit was at 1022. So the develop branch is furthest into the future. That's why you see this ahead of the master branch.
Rafael, I have a question.
Yep.
In the Git log, where do you see merges? Like what shows merges, or does it show merges?
So far, we've only seen one type of merge. We've seen a fast forward merge, and those are not going to be very obvious when you're looking back in the Git history, because that doesn't actually, doing a fast forward merge doesn't actually have to manage your commits. It doesn't create or change your commits at all. It just moves the labels around. So it's kind of hard to tell looking back that there ever was a fast forward merge. But in a second, we're going to see, since both of these commits, both of these branches have changes that the other does not have, we're going to have to use a slightly more complex type of merge. And in that case, you're actually going to see that more clearly in the Git log. So if you can suspend your disbelief for just 30 seconds here, I think you'll get what you're looking for.
And so our fast forward merges, or are those just to for your next commit? That makes sense? Like, is that why you do it? So you could advance your next commit on that branch?
I mean, yes, if I'm understanding you correctly.
Well, just in your words, what are fast forward merges for? Like, what's a, like practically, like if it wasn't a practical like application, like if you were working on a project, why would you do a fast forward merge?
So for one thing, you're never going to have to choose which type of merge to do. You just say git merge, and then Git is going to do the simplest thing that it can. So if what you changed was you just made commits to one branch, so like if you have two branches that are exactly the same, and then you make commits to branch A without making commits to branch B, and then you again want branch A and B to be the same, then that's a fast forward merge where you just bring branch B up to the present with branch A. So just given that specific history of what changes you made to which branch, Git is able to merge them together using a fast forward merge. But that's because of that specific scenario where there were changes to one branch and not changes to another. So oftentimes that's just not what's going to happen at your workplace. Oftentimes you have to merge two branches together, but there was work on the other branch while you were working on your branch. And so Git is not able to do a fast forward merge in that situation. So yeah, you don't need to think about when you're going to use which one. It's just depending on what has changed and how different they are, Git is going to automatically choose a merging strategy.
Okay, that makes sense. Thank you.
Mhm. All right, so this is what the diff shows us now. Our branches have diverged. Now I just typed a git diff master. So remember, I'm on the dev branch. So git diff master is going to compare my dev branch against the master branch. And this is showing me that this is the difference between those branches. Dev is missing the master file for one thing, deleted file, master file.txt. But also dev has this, in addition, text in the dev file. So there are two differences between these branches that we can see here at the command line. All right, so now I'm on develop. So I want to merge these branches together. I want them to be the same, and I want them to both be up to date, basically. So I'm going to have to do this in two steps. First, I'm going to merge master into develop, and then I'm going to merge develop into master. And I'm doing it in that order for a very specific reason. So on develop, first things first, I'm going to git merge master. And then when I do that, it throws me into Vim because it's creating a commit. So this is the difference between the fast forward merge and what I'm doing now, which is called the recursive strategy, which is Git is going to create a new commit. And since it's creating a new commit, it needs a commit message. The default message I think is fine, merge branch master into develop. So I'm just going to type :WQ to save this commit message. Yeah, so now I'm in the develop branch, but I've got the master file because I merged master into develop. Now I'm going to check out master. Now on master, we don't have the text in the dev file. So in order to get master up to date, I'm going to do the reverse merge. I'm going to merge develop into master. Now note that doing the merge the other direction was a fast forward merge. So I knew that this was going to happen. In Git, whenever you have to do the recursive merge strategy, so that's what happened here. When I did Git merge master the first time, merge made by the recursive strategy. When you merge this way, it has to create a new commit, which is a little bit messier than a fast forward merge. But you are guaranteed that when you merge the branches in this one direction, merging them the other way is going to be a fast forward merge. So I knew that the second one was going to be very simple, very clean, and that Git would handle it automatically. So oftentimes when you're merging, things might not always go according to plan. And sometimes when you merge, it'll create a mess and you'll have to clean up that mess. But at the very least, you have control. You can make a decision about where that mess is made. So if you choose to first merge master into develop, then if a mess is made, it'll happen in the develop branch. And then once you clean it up there, you can quickly and easily merge that into master. So that's much better than the reverse situation where you make a mess in the master branch and then you have to, clean that up quickly in a panic and then merge that, fix up develop. Because develop is generally like a lower stakes, lower priority, I guess. Like develop should always have correct working code, but the master branch must always have correct working code. So if you have to make a mess of a branch somewhere, you would generally prefer to do that on the develop branch instead of the master branch. Well, really, other branches would be better than develop as well. The point is just don't make a mess in the master branch. All right, so now we're going to talk about the third type of merge. So sometimes you're going to try to merge two branches together and they're going to be incompatible changes. Just both branches change the same line of text in the same file, for example. So there's just no way that Git can figure out what the correct way to merge those branches in. It's completely ambiguous, and Git is going to need you to tell it manually what the correct version of the code is. So let's get an example of that up real quick here. I'm on the master branch. I'm going to add some text to the first file here. So master says no. I'm going to add and commit that. Switch to the develop branch. and add some conflicting content to our first file. So right now, master says no, develop says yes. These changes are completely incompatible. There's no way that Git can automatically create one commit that has both of these lines on the same line. So we're going to have some problems here when we try to merge. And Git is not even going to try to deal with it. It's going to say, hey, this doesn't make sense. You figure it out. Add it. So now develop added text to the first file. I just want to see what I've done here so far. I can git diff again on master because I'm currently on develop. So it's going to compare my current branch against the master branch. So here's the difference between these branches. On develop, we added the line develop says yes and removed the line master says no. All right, so I'm on develop. So let's try merging master. I'm kind of pessimistic about this, got a really bad feeling, but we're going to try it anyway and see what happens. All right, so git merge master. It is trying to auto merge first file.txt, but there is a conflict, merge conflict in first file.txt, automatic merge failed, fix conflicts, and then commit the results. So this is basically telling me what I need to do here. It's telling me which files it failed to merge. Because normally when you merge two branches, like most of them merge correctly. There's just a couple of files that have issues. And this is going to tell you which files had problems. And then it's telling you that it couldn't fix it automatically. I have to do it manually and then commit the results. So I do git status. The git status is going to reflect that. I have unmerged paths. I have not finished my merge yet. It's showing the files that are problematic. So I need to fix up this file and then I can add and commit like normal, and that'll finish the merge. So now when I look at the file that Git is complaining about, first file.txt, we can see that Git has added some text to this file. So this text does two things. First, it shows me what the problem is, what the two different versions are that Git is confused about. And it also prevents the code from running. So, all these like angle brackets or whatever, this is not valid code in any programming language. So this basically guarantees that I cannot run my application until I resolve this merge conflict. So this is showing me the two different versions of the code. Head is the version on my current branch. I'm on develop, so this is showing develop says yes. And then the incoming change is what I'm trying to merge in. This is coming from the master branch. And so what I need to do is just, well, really all I need to do is add and commit, and then Git will be satisfied. But what I should do is delete code until this looks like how I want my application to be. So maybe I think that the developed version is correct and the master version is out of date. Then I would, delete this caret here, delete these equal signs, and then delete that version from the master branch. And now this is valid code. I can add, commit, whatever. That's cool. Fortunately, though, VS Code gives you this handy dandy little shortcut. So VS Code is aware of the git diff syntax or the git merge syntax. And so like VS Code knows that, all of this is one version, all of this is another version. And so it gives us these little buttons up top, which are pretty useful. So accept current change will put develop says yes into the code and then delete everything else. Accept incoming change does the opposite. I don't think I've ever been in a situation where I wanted to accept both changes. I can't imagine a situation where accepting both changes ends you with a valid program, but I guess that's an option. Sometimes you'll do it. And then compare gives you a nice little git diff in your editor, but I usually just do that at the command line. So we're going to accept the current change because I said just kind of arbitrarily, I think the develop branch has the correct version of the code. So we're going to accept the current change. So now it says just develop says yes. It got rid of all the git merge angle brackets. So git status will show me unmerged paths. It's suggesting I use git add to resolve it. So I'm going to git add dot. Now I have changes to be committed. Conflicts are fixed, but I'm still merging. I have to git commit to conclude the merge. So I resolve the merge conflict on the develop branch. But just like before, I'm now going to check out master. And I'm going to merge develop. So given that I already resolved the merge conflicts on the develop branch, I'm guaranteed that doing this merge in the other direction is going to perform a fast forward. So it's much simpler, just moving the one label up into the present to the same commit as the master label. That ended up making a few changes to the first file.txt, pretty minor. Now, if I do a git log again, we can see. So here was my first branch, and then we merged back in. This one did not create merge conflicts. Yeah. And so then this is my other one where we branched off. We created incompatible commits on each branch. And then when we tried to merge them back in, that created a merge conflict, which we resolved. But then we did a fast forward merge that moved the develop label, or I'm sorry, moved the master label back up to our head. So again, all of our branches are up to date. We've merged them all together. We are in the present, ready to develop more features. So that's as much as I have to say about working on multiple local branches. I think we're about due for questions and a break. And when we come back, I'm going to talk about working on remote branches. But what questions do we have so far about just branching, merging on our local machine?
What was the third type of merge called?
Oh yeah, I should write that up. So the third merge is, not really sure what to call this. Like they just say that there are conflicts when it happens. I don't know, we'll just say yeah. The messiest type of merge is where you have changes to both branches. And so Git cannot automatically merge them for you. Because with the recursive strategy, like Git has to create a new commit, but it's able to do it automatically. So it's not so bad. If there are conflicts, Git has to create a new commit to merge those together, but you have to tell Git what the correct code is using that process I just showed you, where you basically delete the wrong version of the app.
Is the, I know this shows it in VS Code, but in the command line, how would we know about what the problems are in that, or do we have to go into VS Code to fix it like that?
Like what the specific like text issue is.
Yeah, like how you just showed us how we can go into VS Code and you just click the file saying accept those versus the other. And
Mhm.
let's say we're in the command line and we're doing all this. What's the best mode of action if we didn't want to go in there?
I mean, you would have to open the file in VS Code. There's no reasonable way I can think of to resolve merge conflicts at the command line. Like at best, Git is going to tell you which files were problematic, but then I would have to, open them up in my file explorer here and then fix them manually. Also, VS Code has other like features that help you with that as well. So if you're actively fixing up a merge conflict, VS Code will highlight the problematic files in red. So it's like even easier to go to the files that you need to fix instead of just like reading the file name from Git Status and then looking through your folder hierarchy. So VS Code tries to help you out with that a little bit. But yeah, you would definitely have to just open up your editor and then edit the file just the same way you do your regular development.
Awesome, thanks.
Yep. What other questions do we have?
Yeah, Raphael, can you go back to the notes page so I can catch up?
By the way, if you folks want me to slow down or repeat a command or whatever, feel free to just say so. Don't mind, showing you something twice. We've really just got one more section for today's demo. So I think we've got plenty of time if you want to just ask questions or just see things more slowly.
I've got a question, Raphael.
What's up?
How do you get your thing to do the shortcuts? Like you type Git status as just GTS, right?
It's just an alias.
Oh, okay. Can you do it from your command line? Just like do, okay, you put it in your bash ars profile.
So yeah, these are my Git aliases just for things I type all the time. I try not to use them as much for demos, just so you can see commands you're familiar with. But some of this is just me debugging for my own sake real quick, just like what the heck did I just do? So I'll run a Git status real fast. Yeah, as much as possible, I try to make these just like acronyms for the real command so I don't forget what the real command is. I just think I've seen some people who have their editors like customized so heavily that if they're on a new computer, they're just completely useless until they copy over all their aliases. So at least like all of my aliases kind of remind me of what the original command is, like GCO for git check out. Like I'll probably remember the original command if I don't have my aliases available.
I don't know if it's within the scope or not, but say that you're working on a team, everyone's working on their own little branch for their little specific functionality piece they're trying to do for the main project. Whenever they're pulling those changes in, do they typically keep all the Git history of that development or just take the finished commit and add it into the main branch?
I'm sorry, can you explain that again?
So basically, are they going to squash down all of the commit history for the little feature that they have done once it's approved? Or are they going to keep all the Git commit history of that feature when pulling it into the main branch?
Mm-hmm. Yeah, great question. So, as I'm developing a feature branch, I'm going to do it in multiple commits. I've told you before, like I expect my computer to just burst into flames randomly at any point in time. So I'm going to be committing and pushing constantly so I never lose work. But your employer, when they're merging your work in, or well, after they've merged your work in, when they're just looking at the history of the master branch, they don't want to see these like dozens and dozens of like thousand of like tiny commits, like fix a typo or like, removed private keys from public files or whatever, all these like really trivial commits. They don't want to see how the sausage is made. They just want to get the big picture at the end of the story. So it's very common when you merge a pull request that you will squash commits. That means that all of the commits in that branch get condensed down into one single commit that is merged into master. So that way, when you're looking at the master branch, it'll look like every feature was done in a single commit, which some people think is kind of a cleaner way to look at the master branch. It's a better way to understand what's changed over time. In my opinion, it doesn't really matter, honestly. I don't really care if updates to the master branch are in one commit or in a few dozen commits, because you can always use git diff to compare what you want to look at against what you want to compare it to. But this is definitely a very common practice. I would say almost anywhere you're going to work at, they're going to want to squash commits when you merge. I don't think it matters what's locally on your local machine. And when you push it up to GitHub, they'll be able to see all your commits too. I think that's fine. But like there's a checkbox in GitHub when you merge that says squash commits when you merge. And so that's going to not actually apply all of the commits from that branch, but right before it merges, it condenses them into one commit. And then that's what goes into the master branch. So it looks a little more clean, I guess. I don't know. I feel like it's dishonest because there were more commits that were done that aren't in the history now. I like having a big, messy, honest history, but most people don't like that. And I don't think it actually matters all that much either way. Does that answer your question?
Yeah, give me some insight.
Cool. So yeah, squashing branches is cool. Not something you really need to worry about because it's going to be like forced on you by your team. You just kind of follow the procedure and everything's going to go great.
Rafa, I have a question.
Yep.
For individual projects, does it make sense to like have a bunch of branches, or is the branch feature really just for like bigger corporations?
Branching is certainly much more useful when you have more than one person working on a project. Definitely for a lot of my personal projects, I'll just commit everything to the master branch because there's no one else that I'm trying to be considerate of. But even if you are just working by yourself, it can still be valuable to create branches. For example, like if you're not sure what direction you want to take the project in, I guess, like maybe you want to work for a week on just trying something out. You're going to maybe integrate a new API, and it might be the best thing you've ever done for this project, or it might be completely terrible and you want to throw it out. So you might do that new feature on another branch. So that might involve, multiple commits over many days that you're merging in, but you want the freedom to say at the end of it, actually, I don't like any of this, and just forget about that branch, go back to your original master branch. So branching can be useful just to like compartmentalize different efforts, I guess. But
Okay.
yeah, for solo projects, I don't find that that's something I need to do more commonly. I either know what I'm doing or I just give up and do something else because no one's paying me to work on it.
I feel like in solo projects too, the commits is enough. Like you can just, like if you don't like something, you just go back to the previous commit. And then if you want to try something new, then you just try it. You don't like it and check out to the previous commit, sort of, instead of creating a whole new branch.
Yeah, that's more or less what I do. I mean, given that like it doesn't happen that often that I need to check out a previous commit, I'm happy to just like do that work when the need arises instead of using branches proactively. And also given that there's no one else on the project I need to be considerate of. But yeah, I think that totally makes sense what you're saying.
Just a note on that. I kind of wish I would have made a different branch when I was trying to get the Google Auth to work, because I've literally installed so many different things and tried so many different ways that I'm kind of lost in the sauce with my own code at this point.
Yeah, I can see that. Do you at least know about a commit that you could go back to before you
I'm
install
not sure
everything?
right off. I definitely need to get better about committing more often.
Committing often is definitely a good thing to do. Something I guess you could do, in your current situation is just check out your previous commits and see if any of them seem like a better starting point for you to work from. You can use like the git checkout commit label and then a dot just to recreate the past. And if any of those commits seem like they're working for you, or you'd be happy to build off of them, then you can just commit that and say like, okay, this is my new present, and I'm going to work off of this. That's
Rafael,
assuming you committed. Sorry, Edgar.
do you think, when do you think you should commit? Like, should you commit anytime you make a new file, or commit, like, how often should one commit?
Like anytime you can run the application without errors, you should commit. Anytime you've done work that you don't want to do again, you should commit. Like there's really no fear of committing too much. Like some people are like embarrassed about having really small, stupid commit messages or whatever, but like your employer is probably not going to read most of your small commits unless there's like a major incident that they're investigating. And they're going to get squashed when you merge. So no matter how ugly your local branch looks, it's going to look really clean on the master branch. So definitely commit as often as you think is useful. Anytime you've done something, anytime you reach a stable state for your application that you might want to go back to, you should commit, which could be like every 30 minutes, every hour. Because like, anytime you finish coding, you're probably in a stable state where your app can run. But the next time you write more code, you might write a bug that you don't know how to fix immediately. And like, it might be frustrating if you can't immediately get back into a workable state. So yeah, anytime your app runs successfully, I'd recommend committing. And in my personal practice, I probably don't commit as often as I should. I like definitely recommend just committing constantly.
Yeah, I started recently like committing more often, and I think, yeah, it's helped a lot. And I think I've tried to make a branch, but then I couldn't really get it to work, so I just didn't even do anything with it. But usually instead of making a branch, I just make a whole new Git repository. Like I copy the one I like, and then I would paste it into like a new, but now that I know about branching, I'm not going to do that. I'm definitely gonna do branching instead.
I'd
That's what I
encourage
like.
you to explore branches. All right. Do we have any other questions right now? All right. So let's take a 10-minute break. It's almost 11. Let's come back at 11:10. And I'm going to show you how to work with Git branches on remote repositories.
Hey, Raphael, do you mind going back to the notes page before we go on the break? Thank you.
Yep. So for this last part of the demo, we're going to be working on remote repositories. So I'm going to create a repo over on github.com that I will use for this demo. Oops, that's not the button I meant to click. I'm going to create a new repository in my personal GitHub account called Git Demo. It'll be public. Not going to add any of this stuff. Created. Great. So I've now created a repo in github.com, but it's not yet connected to my local repository. So I'm going to go to my local repo. So if I want to know about my remotes, I'm going to type git remote. Currently, I have no remotes, so this command shows me nothing. That's what I was expecting to see here. But now what I'd like to do is add a remote repository. That is, I'm going to add another repo that's supposed to be like a copy or a backup of this repository. So I'm going to grab this URL from GitHub. Git remote add And now I'm going to name the remote. I can call it anything I want, but origin is by far the most customary name for your first remote. So please name it origin. If you do it anything else, people are going to look at you like you're weird. And then paste in the URL of that remote, and then we add it. So now if I run git remote, it's going to show me that I have one remote, the origin remote. It's not very informative though. So I'm going to do git remote -v for verbose. So this shows me a little bit more information, the URL in particular. So I know throughout this course, some people have been having problems where they forked a repo. I'm sorry, they cloned a repo from Quebec Platoon and it wasn't part of their own GitHub account. So one way you can check that out locally is by using git remote -v. And I can see in the URL here that this is fetching and pushing to my local GitHub account, not to the Quebec Platoon GitHub organization. Okay, so now that I have created my repository on github.com, I've added the remote locally. I want to update the remote with my local changes. So who can tell me what command I use to update the remote with my local changes?
Push.
Push. I know you've done this before. So we're going to git push. And then the name of the remote we're pushing to. And now I'm going to show you this with some slightly different syntax than what you've seen before. Master:\master. So what this means is the first branch here is local and the second one is remote. What this means is I want to use my local master branch and use that to update what's on the remote master branch. So like 99.9% of the time, this is how you're going to use git push. You're going to update some branch on the remote repository using a local branch with the same name. Now you need to understand that these are actually different branches because they're in different repositories. One of them is on my local machine. One of them is on github.com. So they're on like physically separate servers or physically separate machines. But I'm saying that the branch locally and the branch I want to update on the remote have the same name. It's master in both cases. Now, since this is such a common use case that the local and the remote branch have the same name, there's a shorthand for this. This is what you've actually been typing. Git push origin master. If you don't have the colon in there, this is a shortcut saying that both the local branch and the remote branch have the name master. So this shortcut syntax is much more commonly what you're going to do, but I just wanted to make it clear that there's a local branch and there's a remote branch. They can potentially be separate. So there will be some instances where you need to push like the develop branch that you have locally onto a master branch of a different repo. So I think like Heroku works like this. For example, Heroku is going to give you, if you choose to deploy with them, they give you a remote Git repository that you can push to, and just whatever you push there gets uploaded to your Heroku server. But you might not want to just push your master branch directly there. You might want to have like a separate branch that you use for deploying to Heroku. So I might be like git branch Heroku to have like the version of my application just for deploying to Heroku. Maybe there are some configuration settings that are different from deploying elsewhere. And then when I go to deploy to Heroku though, I need to push it to the master branch of their server. So that code would look like this, or I'm sorry. So I'm pushing to a remote called Heroku, and I'm pushing a branch called Heroku, but on the remote, they're going to call it master. So sometimes there's a difference in how you name a branch locally and how it's named on the remote. So you would need this syntax. Not a very common need though. I just want you to be aware that it's not necessarily the same on both ends. So let's make another branch here. Looks like I never committed the merge. It's still telling me I have some changes. All right, so I'm just going to do that real quick. Just update the master branch. Okay. So branches, I've got two, develop and master. I'm going to make a new branch. So as you may infer from the branch name, this is a mistake. Let's just say that this is not the branch that I intended to create. But even worse, I pushed my branch. So this is a mistake you might make sometimes. You create a branch that didn't need to exist and you push that branch to GitHub and you want to delete that branch off of GitHub. Does anyone want to guess how we delete the branch off of the remote repository? It uses syntax that you've already seen in the past 3 minutes.
Git Rm.
Not quite. So Git Rm is going to remove local files from your Git repository. It's not quite what we want to do here.
If we push stuff, then we've deleted it locally, will it delete then remotely?
So like what kind of command are you imagining?
Yeah, I don't know.
All right.
So you're saying if we've deleted something locally, we want to delete it remotely as well, or?
Or would you use a -D or -delete?
That's a good guess. That's not what we're going to do here. Actually, I think that does work. Actually, now that you mention it, there are a couple of different ways that you can delete a branch in GitHub, but that's not what I'm about to show you.
Oh, delete a branch. Okay. My mistake.
Sorry. So this is, I think this is kind of fun. So git push origin, I just showed you the full syntax for pushing a branch. Or let's say, oops colon oops. This would say update the remote oops branch with our local oops branch. If you want to delete a branch, this is the syntax for that. So this is still saying that the remote branch that we want to update is oops, but the local branch that we're going to use to update it is nothing. So we're just pushing nothingness onto the remote oops branch. So actually, before I do this, I'm going to go look at GitHub real quick. So I refresh and I've got my master branch. I click this drop down. I have this oops branch. I can check this out. It's got all the same content as the master branch because I haven't made any commits to it, but it is a separate branch that exists on GitHub. So the way that I delete this branch is git push origin colon oops, just pushing nothingness onto my oops branch. So it actually says here deleted. Refresh, I get a 404 page. This branch doesn't exist anymore. The oops branch, master, this does exist. Cool. So I've definitely seen some places where they don't do this. They just accumulate branches in their GitHub repo. And over a while, it just becomes a hassle to look through it. I open this drop down and I'm scrolling for days just to see my future branch. because there are like tons of branches that people don't delete. So I think it's considerate to delete a branch when you're not using it anymore. Okay, so now changing gears a little bit, let's imagine that we have some collaborators that they're going to be making some changes to this repository. So currently we're on the master branch. Now I'm going to simulate having collaborators by just changing these files on GitHub. So there's going to be changes to this repo in GitHub that I do not have locally. I'm going to change the first file. I'm going to add text from github.com. And I'm going to commit these changes right in the web editor. All right, so now the repo on github.com has changes that I don't have locally. So from my local machine, it's going to look similar to as if I just had collaborators that were, changing these files while I wasn't working on them. So if I do git status, it says, everything's clean, everything's up to date, but my local machine doesn't know that the remote repository has updates. It's not checking constantly every second. It doesn't know that automatically. So if I want to get those updates from GitHub, what command do I use to get those updates?
Cool.
Pull. So that is correct. You do use Git Pull in order to get the updates from the server, but that's not what I'm about to show you. What I want to show you now is that Git Pull, the command you've probably been using throughout this whole program, that's actually a shortcut command. Just like Git push origin master is a shortcut. Git Pull is actually a shortcut that combines two different commands. So I'm just going to explain this in a little bit more depth so that you know a thing or two about the internals of Git. So normally when you do Git pull, it takes the changes from the remote repository and then immediately tries to merge them in to your local repository. But that's two steps. The first step is fetching the changes. And then the second step is incorporating those changes, merging those changes into your current branch. So this is git fetch followed by git merge. Now you might be wondering, when we fetch, where do those changes go if they're not immediately applied to our current branch? So I'm going to run git fetch. I think I have to say origin. That might be optional, I'm not sure, because there's only one remote right now. So git fetch origin, and you see it's downloading information from the web. It's updating the master branch. That was the only branch that had any changes. But it didn't make any changes to my current files. If I do a git log, it's showing you that head is still in the same place where it was, referring to master. And I also have the oops branch that refers to master because I have not deleted oops locally. I also haven't merged develop into master, so develop is still one commit behind master. But there's this other commit that's ahead of master, remotes/origin master. So when you do git fetch, Git downloads the information about those remotes into what are called your remote tracking branches. So a remote tracking branch is a branch that Git manages for you locally that is supposed to mirror the remote repository. So it's not constantly connected, so it doesn't always have the most up-to-date information. But whenever you do a fetch, it updates your remote tracking branch, because that's manually saying, update my remote tracking branch based on what's in the remote repository. And also when you do git push, that updates your remote tracking branch, because it's like you just set what was on the remote by pushing. So you know that that's what's there. You can update your remote tracking branch. So you might have noticed a theme here. If you want to look at things that are usually hidden, you can add a -a flag for -all. So these are just other branches that exist on my local machine. And I can interact with them in many ways, the same way I interact with other branches. But Git just kind of assumes that I don't care about them for the most part, and it doesn't show them by default. So if I want to see them, I have to use git branch -a. So here, at git branch, I have develop, master, and oops. Git branch -a, develop, master, oops, and then also remotes /origin/master. So this is just another branch on my machine. Don't get thrown off by the slashes in here. This isn't like a branch inside of a branch inside of a branch. It's just the branch name has slashes in it. Don't think too hard about it. And also, another difference is that I'm never going to commit to this branch manually, but Git is going to update it automatically for me. But still, I can check it out if I'm curious. If I want to know, like, what does my local Git think the remote looks like, I can check out this branch. So now I'm in detached head state again, because I've checked out a branch that's not the tip of my master branch. You know, it's not the present. But this way I can kind of preview the code I was about to pull in. So if I go to the first file, we can see here added text from github.com. Now note that I haven't pulled yet, I haven't merged yet. So this code is not actually part of my local repository in my local master branch. I'm just looking at the remote tracking branch for origin master. Because remember, I just fetched, I didn't merge. So basically what I'm looking at now is this is showing me what I will get when I do the merge. So this is like if I don't trust one of my collaborators, they're asking me to merge some code in, and I'm just like, I want to look at it first. I could do a git fetch and then check it out on my local machine. And then as a second step, do a git merge. So remember, this is just a regular old branch. In many ways, it's just a regular branch. Remotes /origin/master. So if I want to finish doing my manual pull, you know, I said it was a fetch followed by a merge. I already did git fetch origin. So now I can just, first I'm going to go back to master. Okay, so I checked out master. Now I'm going to merge the remote tracking branch into master. Merge. Branch. So this is, you know, breaking down something you already knew how to do into 2 steps. So I'm just trying to help you understand Git at a slightly lower level. Just understand that the commands you've been running are really composed of more basic lower level commands. And so here, doing the merge like this, I've just broken pull into 2 steps. I manually did a fetch, which updates my local tracking branch or my remote tracking branch. And then I did a merge, merging that remote tracking branch into my actual local master branch. So normally when you just do a git pull, both of those steps are done for you automatically. But I just want you to understand a little bit better, just what Git is made of. So yeah, usually though, you're going to trust your collaborators that what they pushed is good, and you should just do your best to merge whatever they've pushed up. So commonly, you're not going to actually do this. You're just going to do a git pull, and then if there are merge conflicts, you deal with them on your machine. But I do think it's a useful way to explore Git, a useful way to understand it. Just helps you appreciate it at a slightly deeper level. Might prepare you a little bit better for further deep dives into Git as you've seen it kind of like broken apart in this way. So I have one more topic I want to talk about that's just kind of practically about how Git is used in companies, but I don't have any more code to show you. So if we have any questions about just the Git commands that I've shown you at the command line here, this would be a great time to pause and ask those questions. I know we've got questions. Andrew, what's on your mind?
If I tried to put my remote to your repository on your account, would it require like you to like add me as like a collaborator or something, or like a username password, or would it allow me to push the code to yours?
You would need to be added as a collaborator, or
Cool.
like authenticate as me when you try to push or something like that.
Okay, but yours is already done because you're already authenticated as you, right?
Right. Yeah, like at the start of the cohort, I would have done the git config whatever's and cache my password so it doesn't ask me for it every time. But yeah, Git is verifying that I am who I say I am whenever I push. Like this is my repo, just random schmoes on the internet shouldn't be able to push to it. What other questions do we have? All right. So last thing I want to talk about this morning is how the heck do people actually use branches? So I've just kind of shown you mechanically like what you can do, just how you can move data around using Git commits and whatnot, just how we can refer to this data and compare things. But like, why do we care about this? Why are we using this? How do people actually use this stuff? There are a handful of different, Git strategies that people use. The one that I've seen most commonly is called Git Flow. It's not the only one, but in my experience, this has been the most common. So in Git Flow, there are two types of branches. We have long-term branches and short-term branches. So the first long-term branch, you've already seen this because every repo starts with this master. I'm going to say /main though, because that's kind of like a more common trend, is that the master branch is called main instead, just to be a little bit more progressive, politically correct, whatever. So generally speaking, the master branch represents live production code, and it must not break. So very commonly in organizations, they'll have automation set up so that when you push to the master branch, that code is automatically deployed to the live site. Like it has to, go through the tests and has to get built. But after all that passes, like there's no other human interaction and it just goes on the live site. So it is absolutely essential that the code that gets push to master is always good. It's always valid, passes all the tests, meets our needs, is not going to upset customers or whatever, because that's what people are looking at live on your site. So the master branch must not break. And even in organizations where they don't automatically deploy the master branch, there's still an assumption that the master branch is always good to go, that there's one team of people like the developers who write the code and will push the master branch. And there's another team of people, the DevOps folks, or product manager maybe, who will deploy the code. And they don't have any way of verifying that the code does what it's supposed to do. They just want to trust that the master branch is good to go. So whenever they need to redeploy the application, they're just going to redeploy the latest commit in the master branch, or maybe the latest tagged commit in the master branch. But somehow they need to have a way that they can know which code is good to go without constantly asking the developers. If product managers have to ask the developers, hey, is the master branch ready to deploy every time you want to deploy? That's going to be a really messy process. You're going to have a bad time. There's just going to be a lot of unnecessary communication. So typically in a well-functioning organization, the master branch is either deployed automatically, or it's just assumed that the master branch is deployable at any point in time. So you would just be better damn sure that there are never any bugs in the master branch. Now the other branch, the other long-term branch, is develop. So the develop branch is what the developers are working on for the most part. You're going to build your individual features, and then they merge into the develop branch. And then the develop branch is what gets tested extensively. You're going to probably have a staging site in addition. So it's just an entire separate copy of the web application that runs the develop branch instead of the master branch. So this way you can test it out in an environment that is very similar to production, but before you actually go to production. So this is not going to have hundreds of thousands or millions of customers on it, but it should otherwise be as similar as possible to the live production site so you can test it accurately. So ideally, the develop branch shouldn't ever break, because when developers are starting new features, they're going to branch off of the develop branch. So develop should be a good starting point for people to do new work. So it shouldn't break. It should be good code. But if the develop branch does break, yeah, the developers are going to need to fix that before they can do anything else. But at least it's not a customer-facing problem. So if you're going to choose between master breaking and develop breaking, definitely better to have problems on the develop branch. But ideally, neither of them should break, because we also have all these short-term branches. Primarily, you're going to have feature branches. So these are going to be named feature slash add sign up page. So this is a reasonable name for a feature branch. You preface it with feature slash, and then some very short string that describes the feature you're building. And again, remember, there's nothing really meaningful about the slash. It doesn't mean that you made a branch inside of a branch. It's just another character in the branch name. So when you're creating a feature branch, you're going to check out develop and then create your new branch and then do your work. When you're done working, you merge that back into develop. It's generally assumed that the develop branch is more up to date than the master branch. So when you're starting new work, you're going to branch off of a develop. So that's what you do when everything is going according to plan, which doesn't always happen, of course. So second type of short-term branch you're going to deal with is a bug fix branch. So you might be like bug fix slash fix sign up page. So this is going to be pretty similar. Branch off, develop, merge into develop. But this is assuming that this is a low priority bug fix, that this is something that we can afford to wait like a few days or maybe even a week on. So maybe like the CSS is broken on the sign up page and it like looks kind of ugly, but like people are still able to use the website. So as long as it's not like a super urgent, like everything is on fire kind of situation, you still want to follow the process, the normal process as much as possible. So even though we're fixing a bug here, we're going to follow the normal process. We branch off of develop. Then when we finish the feature, we merge back into develop. And then when we go through our regular testing, we're going to test the develop branch that gets merged into master. And then when we redeploy master with our regular deployment frequency, that's going to have the updates from develop. But we're not going to like do like an urgent deployment just to get this bug fix out. We're going to deploy the bug fix with our next new version of the application. Like I'm sure you've been to the App Store and whatever phone you've got, and you're looking at the updates for your apps, and they just say like generic bug fixes or whatever. And they weren't urgent bug fixes that they had to push out like immediately, that you had to download right then. It's just the regular like monthly or semi-monthly app update. There's a handful of low priority bug fixes that they want you to install. And so this is the kind of branch you would use for creating those. Just low priority bug fixes that the user can get whenever you deploy the next version of the application. So this is different from the third and final type of short-term branch that you might create, hotfix slash So if you have like a really urgent bug, like the business is just like bleeding money every minute and like everyone has to stop what they're doing and fix this one problem immediately, like before the end of the day, before anything else happens, that is a hot fix. So in this case, we can't wait to go through the normal development cycle where we branch off develop, merge into develop, and then develop gets merged into master with the normal schedule. Instead, branch off master, because that's where we know the bug exists. It's currently live in production. This needs to get fixed right now. I'm going to branch off of master, merge into master, so that the live production code gets the bug fix immediately. It doesn't go through the normal review process. But then when everything is cooled off, we're going to merge master back into develop to kind of get back into our regular development process. So yeah, this is a very common branching strategy. I've done this almost everywhere I worked. You've got two long-term branches. Master is what is live in production. And then there's the develop branch, which is more directly what the developers are working on. So commonly there will be like branch protections on the master branch. So no one can push to master, and merging into master requires approval from like, 2 or 3 reviewers or something like that. Or maybe it requires approval from specific reviewers. There's often just a lot of rules put in place about pushing or merging to master. Whereas develop is usually a little bit more open. This is kind of a shared space where the developers merge their features together. And this branch gets tested extensively by developers, by QA, before we merge to master. But of course, nobody is developing directly on develop. You never actually check out the develop branch and commit to it. You just branch off of it to make your feature branches, like feature / add sign up page. So like 90% of the work you do at any dev shop is going to be on a feature branch that will be named like this. Occasionally, you're going to be fixing things. So you're going to make bug fix branches. If you're lucky, you're never going to make any of these branches, but sometimes that comes up. Yeah. So there are other ways that people work with Git, but this is, I think, the most common strategy, and this is a very contemporary, like modern, popular strategy. Other strategies that you'll see are a little bit more old-fashioned. Like I've heard of people talk about trunk-based development, but I don't think I've ever seen someone under 40 use that phrase, just to put it in perspective. So yeah, I know there are different ways of going about things. So that is all I have to say about Git. There's certainly a lot more to learn, and tomorrow you're going to go, much more in depth in Git and about the internals. I think it's going to be useful, but I was hoping that this would at least be like a practical introduction that can, help you get by in the workplace, help you solve common problems you're likely to run into. Yeah, and that's what I've got for you today. What questions do we have about Git? I know we got some questions. Let's hear it. Or questions that are not directly related to Git, but kind of related about just development workflows and being on a team, or Vim.
I got a question. Are we gonna choose the teams for tomorrow? Because I saw that the guy is gonna teach us tomorrow, saying that we're gonna be in pairs of 3 to 5, or are you guys gonna randomly choose them?
Hang on just a second, actually. I think we're going to choose them. He asked us to do something specific. I'm trying to find it. It was in the, yeah, it's in the Quebec chat. Oh, I mean, we could just do random teams. That's probably the simplest option. Would you all prefer to form your own teams?
I personally would prefer random because it's one less thing to worry about when we're working on our projects.
Yeah, I agree.
That's fair. All right. So tomorrow morning, we will assign random teams for y'all, or would you rather get random teams tonight just so you can like mentally prepare?
I would say tonight, that way we can do the whole creating a repo for a team and kind of get that situated before tomorrow morning.
Okay. I don't think you'll need to do any like technical preparation. I'm sure, he'll walk you through everything you need to do live during the presentation tomorrow. So I wouldn't worry too much about getting things done in advance. But yeah, we should be able to get you those teams this afternoon, just so you know who you're working with tomorrow. Let me just make a note about that to myself real quick. Yeah, so what other questions, comments, thoughts, observations do we have? Someone's got a hand up. Andrew, what's up?
Yeah, I just want to know, have you ever seen anyone catastrophically delete everything?
Not catastrophically. I'm trying to think. No, I don't. That has not happened to me personally, that there was like a catastrophic, unrecoverable Git error that we just like lost everything we needed and we couldn't get it back. Like as long as you don't do a hard reset, or there are a couple of other destructive Git commands, but generally speaking, it's possible to, recover something that you like deleted in the past using Git, generally speaking.
I'm guessing very big companies have like backups of backups too.
Probably everywhere I've worked in mostly pretty small companies, and just GitHub was our backup. But for sure, if it's like a very large company and a very important repo, it would be smart, I think, to have a few backups in other places, just in case something unexpected happens. Or even just like, not even like technical issues, but political issues. Like, github.com has changed hands over the years. So you might be apprehensive about how Microsoft is going to be managing your repos as opposed to the old GitHub corporation. And so you might want to like have your repos backed up just in case of that, just in case the company that owns your repos gets bought out by someone who you don't want owning your repos. And like maybe the first thing Microsoft does is say like, okay, you can only transfer repos outside of github.com if you have a pro account, like a premium account that you pay for. So yeah, since you don't want to be like dependent on some private corporation changing rules arbitrarily, it could be smart to upload your code to other Git repositories. Or a disgruntled employee. That's something I feel like I've heard about happening, just like urban legends kind of. I've never actually seen it happen live, but yeah, that's something you should be concerned about. A disgruntled employee can just delete everything, rebase and squash it so that your whole repo is just permanently one commit that has no information, you can't recover it. So yeah, you should try to like not have weak links in your organization, not create opportunities for one person to ruin everything, ideally. Not always easy to set things up like that though. All right, any other last minute questions today about our Git lecture? And of course, the video is going to go up online so you can review this later in case anyone had a hard time following along. Yeah, if we don't have any questions, then I guess I'll see you all tomorrow. Take care, folks. Wait, actually, hold on, before I forget. Also, we have a Beyond Tech tonight. Almost forgot. So this had to get moved due to John's schedule, but tonight at 4:30, John's going to be talking to you all about the job search. So we're not going to have stand down. Come to the main Zoom room at 4:30. Listen to John talk, share his wisdom with you all. It's going to be great, always is. Yeah, so on that note, that's all I've got to share with you about Git.